Greetings and welcome back to another episode of Bowmaths. In the last video, we discussed how to order fractions, and we talked about how it's not quite as easy as just ordering regular numbers, like regular whole numbers or numbers with decimals in them. It's a little bit more complicated, and we saw some techniques in order to deal with it. So today we're going to be practicing ordering fractions. These first four problems, essentially, I ask you to order the fractions by using a different technique so that you can kind of practice the various techniques. And then this last one's a bit of a challenge problem. So as usual, pause the video, try these out for yourself, and once you've done that, once you've given it a good honest go, then you can watch me go through them and you can see how it's done if you were confused by anything or if you just want to check your work. Alright, let's proceed. Alright, so the first step is order the following numbers by making fractions with a common denominator. So we saw that by making fractions with a common denominator, basically we can just compare the numerators and go from there. Right, so we're just going to put these all as equivalent fractions or expressing the same number but with a common denominator. So let's see what we're working with. So we got 3/4, we got 17/4, we got 7/2, 2.6. We're going to have to put that into a fraction if we want to compare it with denominators, and 5/8, and 3 3/20. And we're going to want to convert this into an improper fraction in order to compare the denominators. So let's maybe start with that. So 2.6 as a fraction, well, we can write that as doing 26 over 10, right? Because that 10 will slide the decimal over 1 to give us 2.6, but this can be simplified down to 13 over 5, right? So 13 over 5 gives us 2.6. Okay, and then for this 3 3/20, we just multiply the 3 and the 20, and we add the 3. So that gives us 63 over 20. Okay, so now we have everything in terms of improper fractions. We need to find the lowest common multiples of the denominators to figure out our common denominator. So what denominators are we working with? We're working with 4, we're working with 2, we're working with 8, and with 5, and 20. Okay, so we have to satisfy all of these numbers. So 4, that is 2 times 2. 2 is prime, so we just leave that as is. 8 is 2 times 2 times 2. 5 is prime, we just leave that as is. And 20, that is 2 times 2 times 5. Okay, so we need to make sure everything is covered. So we'll need 3 2's because that's going to cover all of the 2's, and we're going to need a 5 because that'll cover all the 5's. So our lowest common multiple then is going to be 2 times 2 times 2 times 5, which is 8 times 5, which is 40. So 40 is going to be our common denominator for all these. So now we just want to re-express all of these numbers here, including these two fractions, right, as a fraction out of 40. Okay, so we want to express these as fractions out of 40. So to make 3/4 as a fraction out of 40, we need to multiply by 10, so we get 30 over 40. And then over here, once again, multiplying by 10, we get 170 over 40. And then we have to multiply these by 20 each, right, since 2 times 20 gives us 40. So this one is going to be 20 times 7 is 140 over 40. 13 over 5, we have to multiply them by 8 in order to get 40, right? 5 times 8 is 40. So we do 13 times 8, which should be 104. So we get 104 over 40. 5/8, we have to multiply them by 5 each, since 8 times 5 is 40, so we get 25 over 40. And then 63 over 20, you have to multiply by 2 each, since 20 times 2 is 40, so we get 126 over 40. So now that they have the same denominator, it's as easy as seeing, okay, which one has the bigger numerator and ordering them from there. So we see here that 170 looks like our biggest numerator, so we have first place here. And then after 170, it's looking like 140, so this will be second. And then 126, third. 104, fourth. 30 is actually next. That's fifth. And 25 over 40 will be last place because that has the smallest numerator over the same denominator. So now we just go ahead and order these fractions. And let's use the original numbers they gave us, right? So even though 2.6 is the same as 13 over 5, because the question gave us 2.6, we should use that. So in first place, we have 17/4. And then to show it's greater than, we'll use the greater than symbol, right? So it's greater than second place, which was 7/2, which is greater than third place, which was 3 3/20, which was greater than fourth place, which is 2.6, which is greater than fifth place, which was 3/4, which was greater than sixth place, which was 5/8, and that's it, right? We just had 6 to deal with. So this right here would be our ordering of the list of numbers we were given. And we did that by basically putting everything in terms of an improper fraction that we then took a common denominator of. All right, so for extra practice, make up your own list of various numbers and then use this method on them. Find their common denominator in order to order them. All right, let's go on to question 2. All right, so we have ordered the following numbers by making fractions with a common numerator. So now we're going to use the technique where we make them all have the same numerator, and then we can compare them by looking at their different denominators. Okay, so we have -2, we have 1.4, we have 14 over 15, we've got 21 over 13, and we have -11/2. First of all, we can actually just make the distinction that the negatives, right, those are going to be less than the positives, so we can kind of consider their negatives in their own group, so -2 and -11/2. And we can consider the positives in their own group. So let's start with the negatives. So it asks us to make a common numerator. So to do that first, we got to make -2 as a improper fraction. So that's going to be -2 over 1, right? Now we have a denominator, so we've expressed -2 as an improper fraction, and we want to make a common numerator. So to do that, just like making a common denominator, we have to find the lowest common multiple of 2 and 11. Since 2 and 11 are co-prime with each other, and they're both prime numbers actually, we're going to get that their lowest common multiple is just their product of 22. So make 2 over 1 is a fraction with a numerator of 22. We are going to multiply the numerator and denominator by 11 each, so that's going to give us -22 over 11. And -11/2, we are going to multiply them by 2 each, right? Since that'll give us a numerator of 22, and our denominator is going to be 4. So now we have the same numerator. We just need to compare, okay, which one of these is bigger. So remember, the smaller the denominator, the bigger the fraction, because we're splitting up this 22 into less pieces. If we're splitting up into less pieces, that means each piece is going to be larger, right? Then over here we're dividing by a bigger number. So this is the larger magnitude, right? So larger magnitude, it's farther away from 0. However, because it's negative, it's farther to the left of 0, which means that in terms of the ordering on the number line, -22 over 11 comes to the right of -22 over 4, so we will say it's greater than -22 over 4. Right, so the denominator tells us this has the larger magnitude, but because they're negative, that means it's going to be to the left of -22 over 11. Okay, so we've ordered these, so now we just need to order the positives, and we'll know they'll come after these negatives here, right? Okay, so let's go ahead and do that. So to order these positives, so we need to convert this 1.4 into a decimal, which we can do by saying, okay, that's the same thing as 14 over 10, right? This dividing by 10 would have moved the decimal over by 1 to give us 1.4 back. And then we can say that this is equivalent to 7 over 5. Okay, so just to rewrite here, the fractions we're working with now are 1.4, which equals 7 over 5. Then we have 14 over 15, and we have 21 over 13. And the question again says make a common numerator to figure them out. So we need to figure out what the lowest common multiple of 7, 14, and 21 is. Okay, so 7 is just itself, 14 is 2 times 7, and 21 is 3 times 7. So the lowest common multiple is then going to be 2 times 3 times 7, because that covers 7, 14, and 21's prime factorizations. Okay, so then we do 2 times 3, which is 6 times 7, which is 42. So 42 is going to be our lowest common multiple. All right, so then 7/5, right? We're going to make the 7 into a 42, right? We're looking at the numerators, right? Not the denominators. Let's not get that confused. So we have to multiply by 6, right? 7 times 6 is 42. So we have 42 in the numerator, and then in the denominator, we also have to multiply by 6 to make it an equivalent fraction. So we do 5 times 6, which is 30. So we have 42 out of 30. Next up, we've got 14 over 15. So to make 14 out of 42, we have to multiply by 3. 14 times 3 is 42. So we have 42 on the top, and then 15 times 3 is 45. And then lastly, we are looking at 21 over 13. 21 times 2 gives us 42. So then we also have to multiply this 13 by 2, so that'll be 26. So now we're comparing these fractions with the same numerator over these different denominators. And remember, the smaller the denominator, the bigger the fraction, because we're splitting up into less pieces. So now we just have to see, okay, let's look at their denominators. So 42 over 26, that is the smallest denominator. So that means this one has to be the largest. And then 30, that's our next smallest denominator, so this is second place. And then the smallest one right here is going to be this 45. That is the largest denominator, so that makes this 42 out of 45 the smallest fraction. So now, just adding these to the ordering, our third place is 42 over 45. Right, that automatically beats this negative 22 over 11 because this is positive, that's negative. And then second place, we have 42 over 30. And in first place, we have 42 over 26. Now, this is a little mistake because we want to write it in terms of the original fractions the problem gave us. So I have to rewrite these, and I also have to rewrite these, right? So what were they originally? Well, negative 22 over 4, that was the negative 11 halves. And then negative 22 over 11, that was the negative 2. So that comes next. 42 over 45, that was the 14 over 15. And then 42 over 30, that was the 1.4. And then lastly, 42 over 26, that was the 21 over 13. So we had successfully ordered these. We put them in terms of the original forms that we were given. Of course, this is also a correct statement, but again, we want it in terms of the forms that the question actually gave us. And yeah, so for extra practice, make up your own lists of various numbers and then use common numerators to order them. So use this technique instead of the common denominators technique. All right, so we have ordered the following numbers by considering what whole numbers the fraction is in between. So this technique's a little different, and we didn't really explicitly talk about it in the lecture video, but it's still something that I think is really important to kind of be able to have just so that you can start to intuitively work on these problems a little better. So when we're saying consider the whole numbers the fraction is between, so for example, 5 3/4, that is between 5 and 6, right? This 3/4, that's taking us a bit over 5, but 3/4 is less than 1, right? So we're going to be somewhere between 5 and 6, and we can visualize that on the number line as well. So the idea is if we can express all of these numbers as being between kind of two whole number amounts, then what we're going to be able to get is that if all these numbers are between different whole numbers, it'll be pretty apparent actually how we can order them. So let's look at negative 47 over 4. Okay, so we need to figure out what two whole numbers this is between. So 47, what multiples of 4 is that close to? Well, it's close to 44 and 48, right? So we know that 47 is between 44 and 48. But this is negative, right? So we have negative 48 is less than negative 47 is less than negative 44. You kind of see how that order switched, right? Because now we're going to the left of 0, right? So it's the opposite. So because we have this, we know then that negative 47 over 4 is less than negative 44 over 4, right? And the reason that's useful is negative 44 over 4 is just negative 11, right? And negative 48 over 4, which is smaller than negative 47 over 4, is negative 12. So we see here that we can do negative 47 over 4 as being between two different whole number values. So I hope that makes sense. Essentially, we're just looking for two multiples of our denominator 4 that 47 was between, right, which we found to be 44 and 48. And then using that, because we were looking for the multiples, the fraction basically becomes just a whole number, right? Because they're multiples, that means they're divisible by 4. This was negative 44 over 4, but that's simplified to negative 11. This was negative 48 over 4, but that's simplified to negative 12. I hope that makes sense. So now let's look at 203 over 100. Okay, so what multiples of 100 is this between? Well, it's a little bit bigger than 200, right? So this is bigger than 200 over 100, which is just 2, right? And it's a little less than, and it's a lot less actually, than 300 over 100. So this is less than 3, right? Because 300 over 100 is 3. So we can see that 203 over 100 is going to be between 2 and 3. All right, next up we have 63 over 20. Okay, so what multiple of 20 is this bigger than? Well, 20 times 3 is 60, right? And this is just a little bit bigger than 60. So we would get 3 here, right? 60 over 20 is 3. So this is a little bit bigger than 3. And the next multiple of 20 up would be 4, right? 20 times 4 is 80. That's the next multiple of 20 that comes after 60. So 63 over 20 is between 3 and 4. And then lastly, negative 29 over 7. Okay, so 29, what multiples of 7 does that come between? That comes between 28, right? 7 times 4 is 28, and 38, 5. Okay, but again, this is in the negative world, so we have to switch it all, right? So negative 35, that comes before negative 29, which comes before negative 28, right? As we're approaching 0 from the negative side. All right, so that means over here we're going to have negative 35 over 7, but negative 35 over 7 is just negative 5. And then over here, we're going to have negative 28 over 7, but that's just negative 4. So the two whole numbers that negative 29 over 7 is between is negative 5 and negative 4. So now, why is this useful? Well, let's just draw a number line here, okay? So you've got negative 12, negative 11, 10, 9, 8, 7, 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, and 6. So that covers all the whole number values that we have here. So negative 47 over 4, that's between negative 12 and negative 11. Next up, we have negative 29 over 4 is between negative 5 and negative 4. And then we got 203 over 100. That's between 2 and 3. And then between 3 and 4, we have 63 over 20. And then between 5 and 6, we've got 5 and 3/4. So we have just ordered all of them, right? We see very clearly what their order is on the number line. Negative 47 over 4 is last, and then that is less than negative 29 over 7, and then that is less than 203 over 100. And then in second place, we've got 63 over 20, and then greater than all of these is 5 and 3/4. So you see how this is a kind of a really useful method? Instead of looking for a common numerator or a common denominator, we can just see, okay, what values are these fractions all between? And then we can use that in order to very clearly kind of see which one is bigger than the other. So one maybe shortcoming of this technique is, what if we have two fractions that are both between the same two whole numbers, right? Like what if I took a fraction like 5 and a half, right? So 5 and a half, that is also between 5 and 6, right? So then we would still have to compare between 5 and a half and 5 and 3/4. So then you might have to go ahead and use one of those common denominator or numerator techniques in order to compare them properly. But this still gives us a way to maybe compare a lot of our fractions, right? And maybe gives us a faster way of doing it. So for extra practice, make up your own lists of various numbers and try to consider the whole numbers the fractions are in between, like we did here, in order to help you. Again, it's not going to be guaranteed that that will totally order your list, because you may get multiple numbers between the same two whole numbers, in which case, yeah, you'll have to go back and use some other techniques. All right, so here it says order the following numbers by converting fractions into decimals. Okay, so for this one, we know it's pretty easy to compare decimals, right? We just look at what numbers are bigger. So one reasonable technique, especially if we have a lot of decimals, is why not just convert the fractions into decimals, and then we can see which one's bigger. So let me write this out. We got 3.2, 3.5, those are already decimals. But then we got 17 over 5, so we got to convert that into a decimal. 3 and 8/9, we got to convert that into a decimal. And 32 over 9, we got to convert that into a decimal. Okay, so let's start with the 17/5. So to make that a decimal, we just do some long division, right? So we could do long division. However, if you recall from a previous video, I actually did a whole mental math technique on doing 17/5. So that is just going to be 3.4. And if you don't know the mental math technique, I would strongly recommend you go check out that video because it's really interesting and really useful because you can just do this like immediately in your head. So I'll link that in the description of this video. Next up, we have 3 and 8/9. So to convert a mixed number into a decimal, we just have to look at the fraction part and convert that into a decimal. So 8/9, we'll do 8 divided by 9. 9 can't go into 8, so we have to put a 0 here and then add our decimal point because we are at the 1 spot, so now we need to be adding extra zeros here. So we have 80. How many times does 9 go into 80? Well, 9 times 9 is 81. That's really close, so that means it can only go in 8 times. 9 times 8 is 72. Subtract it off, we get 8. Bring down the 0, we're at 80. Okay, same thing, right? 9 times 8 will give us the 72 we need, but we're just going to be stuck in this loop, right? So this is just going to continue on like this. So we are going to get that 8/9 is 0.8 repeating. So with the 3 on top of it, this then just becomes 3.8 repeating. So that is this as a decimal. Next up, we have 32/9. All right, so let's do the long division here. 9 doesn't go into 3, but it goes into 32 3 times, right? 3 times 9 is 27. Subtract that off, we get a 5. Okay, we're at the end of the row here, so we need to put a decimal and start doing zeros. Bring down a 0, we have 50. 9 goes into 50 5 times, right? Since 9 times 5 is 45. All right, so then we subtract 45 off at 50, and we get 5. Bring down a 0. Oh, once again, we're at 50, right? 9 times 5 gives us 45, and this is just going to keep repeating. So we then get 3.5 repeating for this 32/9 fraction. Okay, so now they're all expressed as decimals, and now it's going to be really easy to order them all. So the smallest one here is 3.2. And then the next smallest is 3.4. But again, 3.4 was 17/5, right? That was the original fraction. So we'll write 17/5. And then after 3.4, we got 3.5 and 3.5 repeating. So this is 3.5, but this has a little bit more, right? It's 3.5, and then it goes over a little bit more, right? Because of that 5 repeating. This is 3.55555. So 3.5 is a little smaller than that. So that is going to be next, 3.5. And then afterwards, yeah, we got our 3.5 repeating, which was the same as the 32/9 that the question gave us. All right, and then afterwards, we have 3.8 repeating. All right, so 3.8 repeating, that was our 3 and 8/9. And then lastly, we have 4.2, right? That's not even in the threes, it's way bigger than the rest of them. So this right here will be our ordering. All right, so once again, another possible technique where we just convert the fractions all into decimals and then just kind of compare them as we know how to do. And then so for some extra practice, make up your own lists of numbers and order them by converting fractions into decimals, just like we did here. And then once you've done that, for extra practice for kind of like questions 1 through 4, make up lists of numbers and then try and combine all the techniques that we've done, right? So basically just don't try and restrict yourself to any technique. Just when you're comparing two numbers, think, okay, what technique would be best here? Maybe it's making a common numerator or denominator, depending on which looks easier to do. Maybe it's noticing that, oh, this number is between these two whole numbers, and this one is between two different whole numbers, right? So then you can compare them that way. Or maybe it's by converting a decimal into a fraction, or a fraction into a decimal, right? So there's a lot of flexibility here, and it's going to be up to you to just get a lot of practice to determine kind of what's the best one to use. All of them will work, but the more practice you get, the faster you're going to get at it, and you're going to be able to figure out the most efficient way of going about the problem. Okay, so let's do question 5. All right, so we've got two fractions here, 400,003 over 400,007 versus 500,003 over 500,007. So these are two absolutely monstrous fellows here. And in order to compare them, yeah, we could, if we really wanted to, convert them into decimals. That would be gross. Or we could, if we really wanted to, compare their numerators by making a common numerator, but that would be awful. Or a common denominator. Once again, that would be just egregious. And they are also both between 0 and 1, right? Because these are both just regular proper fractions, right? The numerator is smaller than the denominator. They're both positive. So none of the techniques that we have really look all that appealing in order to compare these. So maybe there's a trick that we can do with this, and indeed there is. So what I'm going to notice is that these two numbers kind of have the same pattern, you could say. This is 400,000 with a 3 over 400,000 with a 7. And this is the same thing, except it's just 500,000 instead of 400,000, right? But notice that the difference between the numerators and the denominators is still 4 in both cases, right? 400,007 minus 400,003, that is 4. And 500,007 minus 500,003, that is also 4. So these are kind of similar in the sense that over here, we are just 4 away from having 400,000 over 7 over 400,000 over 7. But that's just 1, right? So we are 4 of this numerator away from getting 1. How could we maybe use that? Well, couldn't we then write 400,003 over 400,007 as being equal to 1 minus 4 over 400,007, right? If 400,003 is just 4 away from getting 400,007, which would make this into a fraction where the numerator and denominator are equal, which would mean the fraction equals 1, then this is basically just 1, but we've taken away 4 of these 400,007ths, right? So I hope you can see that. And if you really want, you can make this into a fraction with a common denominator, do the subtraction, and you're going to see you get the same thing. But I hope you can see that 400,003 over 400,007 is just basically 4 taken out of a whole number amount where we have the full 400,007 over 400,007. So I'm going to do the exact same thing with 500,003 over 500,007. So then this becomes 1 minus 4 over 500,007, right? Because the difference between the numerator and denominator is just a 4. So now this becomes a lot more interesting because these two fractions are easier to compare, right? So let's just compare 4 over 400,007 versus 4 over 500,007. They have the same numerator. Wow, so we can actually compare these really easily because we have a technique for that. We know that if they have the same numerator, we can just compare their denominators, right? So what was it again? The larger denominator, the smaller the number was, right? Because we're dividing into more pieces. So since this has a larger denominator, this one here is smaller. And this one here is larger. So when you see, oh, this is larger, then the bigger one has to be 400,003 over 400,007, right? Well, hold your horses. This is the larger one out of these ones with 4. So that means over here, we're doing 1 minus the larger one up here, right? If we're doing 1 minus a bigger thing, well then, wouldn't this make it the smaller one? Right? If we're taking away something larger out of the same amount, then it would actually become smaller. And then similarly over here, we're taking away the smaller thing from the same amount, so this would actually be the bigger one. So then the answer is the larger fraction is going to be actually 500,003 over 500,007. So I hope that made sense. We just converted these, and we noticed it's subtracting two fractions with the same numerator. So we compared those fractions. We found that this one was the bigger one because it was out of a smaller denominator. But since it's the bigger one, we're doing 1 minus the bigger thing. That basically led it to being the smaller amount. And then similarly over here, we're doing 4 over a larger denominator, so that made it the smaller thing. But since we're doing 1 minus the smaller thing, that means it's going to be the larger amount. All right, so I think that's a really cool question and kind of uses a fun little trick there. And I hope you enjoyed it as well. But that's going to do it for today's episode. I hope you found this useful. I hope you found it interesting. And yeah, have fun with ordering some fractions. But until the next video, you have a good one, you stay groovy, and I'll see you then.
Bow Maths.